Hi, so in this video we're gonna discuss another model from the family of new trade theory / new economic geography models, and this one is based on Krugman's article from 1991 titled Increasing Returns and Economic Geography. So what we're gonna do in this video is to design the general outline for the model and prepare the ground for the further analysis. So we start with assumption about preferences, and we assume that preferences into regions are in symmetry and that they are defined by Cobb-Douglas utility function, where CM stands for consumption of manufactured goods, CA stands for consumption of agricultural goods, mu denotes the share of manufactured goods in total expenditure, and 1 minus mu denotes the share of agricultural goods in total expenditure. So the latter two features of this function arise from the functional form of Cobb-Douglas utility function. So basically this will apply to any function of this type. Upper coefficient of the particular commodity will denote the proportion of income spent on this commodity. So CM denotes the total consumption of manufactured goods. So in this formula, N stands for the total number of goods consumed, and sigma, which always yields the value above 1, stands for the elasticity of substitution of the good. Basically it can be described as elasticity of demand the individual firm I faces. There are several assumptions regarding labor force. So first of all, we assume that for two sectors, which are agricultural sector and manufactured sector, there is a unique type of labor force. So peasants work in agricultural sector, and agricultural sector employs only peasants. Workers work only in manufactured sector, and manufactured sector employs only workers. We assume zero inter-industry mobility, which means that laborers cannot change their occupation, and we assume that workers are perfectly mobile. So basically laborers employed in manufactured sector are free to move from one region to another. At the same time, we assume that peasants are perfectly immobile. They cannot change the region. We denote the total size of labor stock in both regions as 1, and we denote worker supply in both regions as mu. So if L1 stands for worker supply in the first region, L2 stands for worker supply in the second region, then total worker supply in both regions is equal to mu. We assume that number of peasants is the same in both regions, and it can be calculated as the total size of labor force, including laborers of all the types, minus number of workers divided by 2. So this is peasant supply per region. As usual, we assume economies of scale, and this feature is captured by the cost function. So here you have cost of production expressed in real terms, which means that it is expressed in terms of labor requirement. So LMI stands for number of units of labor force employed in manufactured sector AI. Alpha stands for fixed cost, or basically the cost which does not depend on the level of production, and beta stands for the constant marginal cost. So in this case, when we assume non-zero fixed cost and constant marginal cost, we can easily detect that increase in the volume of production will result in decrease in per unit production cost. So if you divide both sides by xi, you will get per unit production cost expressed as alpha divided by x plus beta. So again, as I mentioned, when volume of production increases, per unit production cost will decrease. So we can express cost of production in nominal terms, which will be useful for the further analysis, by multiplying both sides of this equation by W, which would stand for the wage of worker employed in this sector. So in this case, nominal cost of production will be equal to W times alpha plus W times beta times xi. So in this case, expressed in nominal terms, marginal cost is equal to W times beta. We assume that transportation costs take the fixed fraction of the good, and this fraction is equal to 1 minus tau. So basically tau, which always takes the value below 1, reflecting the fact of non-zero transportation costs, describes the proportion of the good that arrives to the other region. So speaking very informally, we assume that transportation costs just eat some portion of the value, and this proportion is always fixed. At the same time, we have to impose kind of restrictive assumption. So in order to keep the wages of peasants equal in two regions, we have to assume zero transportation costs for agricultural goods. So basically we assume zero transportation costs for agricultural goods and non-zero transportation costs for agricultural goods. For manufactured goods. Okay. So as we discussed in the previous video, under assumption of non-zero market power, or basically imperfect competition, profit maximizing firms will charge the price which is equal to marginal cost of production times markup. Markup is calculated as elasticity divided by elasticity minus 1. And as we discussed at the very beginning of this video, in this model, sigma stands for elasticity of demand the individual firm faces. So we calculate price markup as sigma over sigma minus 1. So due to the assumption of symmetric technologies and preferences in two regions, we calculate price. The representative firm from region 1 charges P1 as sigma over sigma minus 1 times beta times W1, and analogously we calculate price. The representative firm from the second region charges, the structure was too complicated. We calculate price charged by representative firm from the second region as sigma over sigma minus 1 times beta times W2. So in this case, since this fraction will be identical in both equations, we can calculate the ratio of prices into regions. So basically P1 over P2 as the ratio of wages into regions. So we just have to divide this equation by this equation, and this is what we get at the final result. Finally, as we discussed before, assuming imperfect competition or monopolistically competitive market, we deal with 0 barriers to entry and 0 barriers to exit. So this is the feature which draws the borderline between monopolistically competitive markets and monopolistic markets. So due to the absence of barriers to exit and barriers to entry, all the firms operating on the monopolistically competitive markets have zero profit in the long run. So this is what we call zero profit condition. We calculate profit of the representative firm from the first region as follows. So P1 times X1 is equal to total revenue, and total cost can be calculated as wage paid by the representative firm times labor requirement. Because as you remember, L was equal to alpha plus beta times X1. So the difference between them should be equal to 0, indicating zero profit in the long run perspective. So we can rearrange this equation. This is what we get. And we can also express X1 as the function of alpha, wage, price, and beta. This is what we get. And as we discussed a minute ago, you can express price as the product of marginal cost and price markup. So basically here we can replace P1 with sigma over sigma minus 1 times beta times W1. Here we have it. So we can put beta times W1 in front of bracket. This is what we receive. Then we can simplify this equation a bit. This is what you get. Finally, you rearrange, and this is your final answer. So X1 will be equal to alpha times sigma minus 1 over beta. And due to our assumption about symmetrical preferences and symmetrical technologies, X1 will be equal to X2, and again, they will both yield the same value. Okay, so we assume that C11 stands for consumption of the representative product produced in region 1 in region 1, and C12 stands for consumption of the representative region 2 product in region 1. So basically region 2 serves as the adjective in this case. So first of all, as usual, in order to define the optimal, in a different way. So in order to define the relative demand function for, these products or the optimal value of consumption, we have to equalize marginal rate of substitution of these two goods, like basically consumption of representative region 1 product in region 1 and consumption of the representative, region 2 product in region 1. So you have to calculate marginal rate of substitution, which again is calculated as the ratio of first derivatives of aggregate consumption function with respect to these variables. And this is what you get. In optimum, the ratio of effective prices should be equal to MRS. So in our case, the price of the locally produced good is equal to P1. At the same time, the effective price of the good produced in region 2 will be equal to P2 over tau. So here you can already see the final result, after everything was rearranged. So if you calculate this to the ratio of prices, we can put both sides to the power of sigma. So this is what you get. And as you remember, P1 over P2 is equal to W1 over W2. So that's why we can replace this ratio and get this result. So now we introduce Z11, which is the ratio of region 1 expenditure on local manufactured goods to the expenditure on manufactured goods produced in the second region. And this is how you calculate this. So the idea is like this. The bigger the number of goods produced within the region is, the bigger is the share of this product in the expenditure, regardless of the price. And this is reflected by this ratio. And basically the product of prices and consumption stands for the value of expenditure per se. So one of the implications of zero profit equilibrium is that the number of goods produced in the region, the ratio of the number of goods produced in the region to the number of goods produced in the other region should be proportional to the ratio of to the relative size of the labor force. So that's why we replace N1 over N2 with L1 over L2. And as we discussed before, the ratio of prices is equal to the ratio of wages. So this is the final result we end up with. It will be very similar for the second region. The only difference will be that in this case, good 1 will be transported instead of good 2. That's why it will be just inverted. So instead of P1 times T over P2, we will have to multiply P2 by T. Okay, so here we calculate the income of the labor force in the first and the second region. So wage of the labor force in the first region times the number of manufactured workers in the first region will be equal to the proportion of income spent on manufactured goods times income in the first region, and this ratio will denote the proportion of income spent on the locally produced goods, like the goods produced within the first region. Analogously, this will stand for the total expenditure on the goods produced in the first region, made by the consumers from the second region. So Y2 stands for the income in the second region, and this ratio will stand for the proportion of income spent on the goods produced in the first region. Here we have it. Analogously, you calculate the income of workers in the second region, and from this you can calculate the level of income in the first and the second region. So again, everything will be pretty symmetrical. So in the first region, income will be calculated as the income of the labor force plus 1 minus mu divided by 2. In the second region, it will be calculated as income of the workers plus 1 minus mu over 2. So you can just derive it from these two equations. Okay, so here we introduce F, and basically F stands for the, how to say it? For the ratio of L1 to mu, and as you remember, mu stands for L1 plus L2. So basically it just tells you what is the proportion of workers employed in manufactured sector who work in the first region. Yeah, this sounds appropriate. So as you remember, per unit cost of production will be negatively dependent on the stock of labor, and price is directly related to the per unit cost of production. So in other words, bigger regions with the higher stock of labor, bigger stock of labor, will face lower prices, and we can describe the general formula for overall price level in the first and the second region following this equation. Okay, so finally, we define real wages as nominal wages deflated by the price level, and this is what you should get. So now the question is whether, because as you remember, F stands for the share of worker supply employed in the first region. So now the question is whether higher stock of labor in the first region, so basically higher value of F, will be associated with increase in this ratio, indicating that regions with the higher stock of capital indeed have higher wages, or it will be the opposite, so it will be associated with decrease in this ratio. So here you have the formula, and we will get back to this next week, but you can get additional points, let's say 5 additional points for your coursework, by analyzing the relationship between price-wage ratio and the share of labor force employed in the first region depending on transportation cost. So I already give you a hint. You can assume the same values for sigma and mu, and you have basically what you have to do, is just to analyze what is the relationship between the ratio of real wages and F depending on the assumption about the size of transportation cost. Okay, so good luck. If you come up with everything, it can be formal mathematical analysis, you can use derivatives, or you can just try to figure out how it looks like for the different values of F, basically doing some kind of simulation. So it's up to you. Okay, so that's it for this video, and thank you for watching.